Hello, everyone. Good morning.
Hey, good morning.
Morning.
Good morning.
Okay, is there anything we need to talk about before jumping into the spec? Okay. So we had a short meeting last week and reviewing the opens that included error and how we want to show error and pass error, and also on the configuration status registers we had some thoughts. That's where we were. Brian, would you be able to lead the discussion?
I can talk to it. Unfortunately, I'm at I'm at a conference. I'm in Embedded World North America, and so I don't actually have my laptop in front of me.
I can share my screen.
Okay. So I guess on a related topic, while you're doing that, I emailed Alad, and he said the the frame signal is intentionally undocumented. So they want people to do whatever do with it whatever they want. I did ask for some follow-ups, and he's hopefully he'll get back to me. Hopefully, but it sounds like whatever we do on our spec isn't going to step on the toes of the bow spec, because the bow spec intentionally doesn't talk about it because they want people to have flexibility with the sideband. I'm not sure how I feel about that.
Yeah, I was going to ask how you thought about that. I mean, that just seems like an opening for problems.
Yeah, I agree. But I think what makes the most sense is just try and do what we think is right, and then intentionally try and get their blessing, and maybe they'll pull some of our wording into their spec.
Do you get the impression that he wants us to? I mean, he's my boss, so I should be talking to him myself. But do you get the impression that he wants us to like put into our spec things that all of us think should be in the PHY spec? Does he like is he leaving it open at his level?
He is intentionally leaving it open. Hold on, let me see if I can. His exact wording was the bow PHY spec intentionally doesn't say anything about how the frame signal should be used, so that if for some reason differing higher levels need to use that signal differently, they can do so. So if the question is about the bow PHY potentially colliding with something you are doing, you have carte blanche. Now, I don't.
So
again,
Brian,
I followed up with some specific. Go ahead.
Just a quick comment on that, right? So I asked a specific question when in the other meeting as well, when that was being put together, and the intent was not for some other higher functions to use the same set of PHYs. The intent was basically to have multiple instances of the sideband PHY, and some other instance could be doing something else. So their main intent was basically to overload the bow sideband to do a lot of other things. Like for example, if there is a low frequency temperature sensor data that they want to transmit from one die to another, they would be using one dedicated set of sideband PHYs, and that would be doing the hardware on both sides to identify that. And the reason why they did that is because the way we use the sideband spec at the link protocol level, we need a bidirectional sideband. But then the PHY guys, they figured out that there are other use cases where you could have just a single direction sideband signals that could be used for transmitting some sideband low frequency data that needs to be constantly monitored, like some telemetry data that needs to be constantly sent from one chip to another. So yeah, I did ask this question: is the intent whether that a higher function would access the same sideband for doing something else? And that answer was no. So I don't know if that changed, but if that changed, then probably I can go to Elad and I can ask him again.
So you're saying that the BIO sideband is potentially for multiple purposes, but
Correct.
they would potentially have multiple instances, multiple pins with BIO sideband, and people can just
Correct.
do whatever they
Correct.
want on it.
Correct. So they'll be just using the file layer, and they'll be instantiating the same file layer for doing other stuff other than what we want for control spec. And that was the intent behind leaving the framing signal out of the phi spec, because the framing signal is required by our control path spec, because we basically transmit some known packet structure. But apparently there were use cases
Yeah.
from other companies where they wanted just a unidirectional communication between one chiplet to another, not
Yeah.
expecting anything back in
Yeah, I
return, and wanted to. And since these files were already defined, which were supposed to work properly without a calibration sequence required, they thought of reusing the same set for other purposes.
Yeah,
But
I
not
see.
the
I
same
see what you're saying.
instance.
I see what you're saying. I think that's. I understand the motivation. I think that's the wrong way of going about it from a standards perspective, but that's fine.
Yeah, I mean, I agree. I mean, I mean, when this, so I entered this, I remember entering this discussion midway, and I was thoroughly confused what was going on. So I had to ask,
Yeah.
and that was the motivation behind doing all of this. But that said, I mean, I feel that the sideband spec should probably um, um, include the definition of the framing signal, with a side note saying that there are I mean, with a specific side note saying that implementers can choose to instantiate multiple variants of this file for other purposes other than what is required for link bringup. But I think that text probably never went in. So if we feel from a link layer perspective that such a text should exist in their file layer spec, then I think we can collectively ask them to include that text.
Yeah. Or alternatively,
Yeah.
if we're going to be the guys that are defining what the message looks like, right? The message format looks like, and it's not going to show up in the phi spec, which is perfectly reasonable, I think, then perhaps maybe we should just define our use of the frame signal as well. Right. I mean,
Well,
it's not,
yeah. Well, we have to. But I think. We have to define how we're using the frame signal, which I have text in there that says, it has a proposal for it, right? But I don't think, whether that needs to get pushed down into their spec or not, I think is the real question.
yeah, I know we all agreed that that's what we wanted, but it sounds like that's not what they want. Right. That they want. Right. It sounds like that they want to allow even like the data signal, right, to be different things, right? It doesn't have to be our definition of a message.
No, data signal's tightly specified in there. And well, not tightly specified. It is specified. It's clock alignment, et cetera, and we're replicating that text in ours. But we replicate that so that we can reference, so that our text around the frame signal makes sense, right? Because without it, as you're like, okay, use the BAL spec, and then frame is like this. It's like so I only replicate. It's only replicated so that we can talk about frame. My opinion would be, if I was adding text to theirs, I would say something along the lines, you start a sentence. Optionally, the signal, this interface may also use the frame signal as such, right? And then people have the option to do that for packet-based stuff like we're doing, or if they're doing like what Rom said, some sort of raw data temperature stream over sideband, which why would you be doing this on like, oh, I guess the data streams over bow. I don't know what you're using they're using sideband or something else, I guess. And then, then they just they optionally don't worry about the frame signal, right? Leaving it just completely open, leads to a lot of ambiguity, right? And people like think, oh, there's no protocol for this. I can, do whatever I want. And then they get they get screwed halfway down the pipeline when they realize, oh, there was another spec this information was in, I should have implemented, right?
Yeah, I mean,
Yeah.
I agree with Paul on that. I mean, like I said, right, I think we should. I mean, the main purpose of sideband should also be specified in their file layer, so that people who are trying to develop logic behind it know what is the main use case. And then, I mean, to be honest, I did not understand why they want a separate spec, why they couldn't use the same framing structure for doing any telemetry that they require. But apparently, there are some more automotive use cases where they wanted to send some raw bit patterns across from one chip to another. So, but then I'm in agreement with Paul that we probably need some kind of cross-referencing in both specs to say what the framing signal should behave like.
Yeah. Yeah, I agree. So that maybe that is maybe like you said, Ron, maybe it's as simple as a cross-reference, maybe where they say they just add a note right there saying one implementation of it is in this link, right? And you guys can go implement this if you're doing packet-based message transport. And so that people aren't quite as confused when they look at that.
Agreed.
I'm trying to find where that exists in this document. I can't
It's in the
find it.
sideband protocol section. It's under
I think it is
sideband.
section 18. I don't know the news. I don't have access to the new draft spec, but the old draft spec, it was section 18.
You're talking about for the bow spec, right?
Oh, for the
Oh, the
for the
box.
bow spec,
Yeah,
yes.
For our spec, it's in the sideband protocol section. Yeah, right there. Just scroll down a little bit. Let's see.
This one.
Sorry, scroll back up. Keep going. Keep going. Keep going. Sorry. It's in the new wording that I added for. It's at the top of the new wording. It talks about the protocol before it talks about the transactions. There you go. That paragraph right there.
Okay.
And I basically just define some behavior for frame. And then again, this is just a rewording of what Boppy, whoever made that like bullet point list down there that I crossed out. And then again, I'm just assuming frame is basically a valid signal, and it is syncs to the transmitted clock the same way that data does. So rising edge on the transmit and falling edge on the receive.
Right, and I don't recall if that frame is supposed to just mark the first bit of the frame, or whether it is supposed to stay throughout the duration of the frame. I don't recall what was the final decision on that, but it was one of the two.
It wasn't documented, so I assumed it was a valid. So
Okay.
you have to keep it up. But again, if you guys disagree for that, if there's a reason to make it first bit, then I don't care.
No, I agree. I think that's what we decided on,
Which one?
to make it be a valid bit,
Okay.
but it's active during the entire message.
But then we also probably need to say it should drop and raise back again between two frames, correct? I mean, when you're sending back-to-back
I
frames,
have
you
a,
need to.
Yeah, he says that.
yeah.
Okay, he says that. Okay.
Yeah, I
Okay.
have a
Sorry,
minimum time between when it goes down.
Okay, perfect. Okay.
What can we do in our side, and do we need to be more persuasive with the file layer?
Like, I think as we were saying earlier, I think we need to get our ducks in a row and make sure that we're complete on what we think is here, and there's not another open on that side, and then just send it to them and say, hey, this is what we're doing. If you guys would like to take this, please do. Otherwise, if you could like add a link, in that section so that people understand, the the other layer that we're doing, is how they're using this, right? As a reference. So that people are more likely to pick that up if they're trying to implement something that is going along with the standard. But we're not obviously not published yet, so that wouldn't go in there till that, but still. Because it doesn't sound like they're inclined to just add a lot of text there because there's other use cases.
Okay, I like that plan. It makes us make it allows us to make progress without depending on the other spec.
And again, per Alad's email, I think we have permission to make progress. As it was. Doesn't sound like we're stepping on anybody's toes at the moment.
So Brian, just my opinions here. So I do believe we need a timing diagram for your note down there. I think that would be
Okay.
very helpful. And then do you state anywhere what the first data bit is that's transmitted?
No.
We need to do that too.
In terms of like Indianness?
Yes. Yeah, whether it's the MSB or the LSB.
Yeah. I think we do say Little Indian somewhere, but I'll go look for that and see and make sure that it says it somewhere.
Yeah, I mean, we can clearly state that in the timing diagram, show that data bit 0 goes out first, or message bit 0, whatever. To be clear.
Sure. I might. Okay. I think we can. Do we want to move on to error stuff?
Okay, I think that's a good plan. Let's move to the error. Ram, do you have something to share? Is there part of this document that I can go to?
No, but I can speak for it. I mean, I did read some of Brian's questions on the error stuff, so I can definitely speak for it. I didn't get a chance to add the notes to the document, but I can definitely say what I feel, and then we can then take it from there. So from an error perspective, right? So there are like multiple different types of errors, and most of it is contextual. So at the very base layer, right? So we can have protocol level errors where the packet itself is bad, meaning the ECC failed or the parity failed. So we have one level of error where the packet itself has to be dropped because the integrity check failed. The next level is getting some spurious packets. For example, if we got a response packet, a response command, the command field indicated a response, and the other side is not waiting for a response. So there was no pending request for which the response could be matched up. So that could be the that's the second level of error. The third level is the decode errors. So if you're trying to write to non-existent CSR on the link partner, then when you initiate a bus transaction into the CSR bus for the partner, you will receive a decode error. So that's the third type of error. And then the fourth, and beyond that, I think we have contextual errors where we want to say if a certain stage of the bring up failed or not. I mean, and in some cases we also need ACT. But ACT is not an error technically, but we need to know if there was any convergence issue with a certain calibration step. So these are the different levels of errors that we could get, right? And then at some point during the spec discussion, we agreed that we don't need the error type command in the field because most of these errors could be technically be communicated via the partner message as well. And I'm not sure what all errors we want to communicate with this error command type. So that is something we should probably agree as a group and just make a note of it in the spec and move forward. Because everything that we want to communicate, we can also communicate via the partner messaging.
Yeah, so I think as the consensus is we're not defining the messages themselves and we're not defining where errors can go. We're just adding multiple possible ways to convey errors, right? I think the thing we need to document though is if you're conveying errors in this method, what is the protocol or procedure that you do to convey that error? So like you said, some errors you potentially can write to the partner message, right? I think we need some sort of statement saying that is that is one possible behavior. And then we need another statement around the sideband phi error register. What is the way you convey error here? Do you write that to your partner? One of them is called local error, right? You said, so you write it to your local error register and it is incumbent upon the partner to read that register. Is that right?
No. So that local error is for the local processor. So say, for example, we dropped a packet because of a parity check or an ECC check. Then we need to indicate to the processor on that side saying that there was some integrity issue with the sideband signal. So that was what that local error register was meant to do. But at the same time, we also need to communicate to the partner that we had to drop a packet because of an ECC error. And sometime back, there was a consensus that we can do all of that through the partner messaging register as well. So
Hold on. Let's talk about one at a time here. So the local error message, that is for if the controller drops one for ECC so that the local CPU can read it.
Right. I mean, if you want to capture the syndrome and whatnot, so you need to let the local CPU know that there was an error. You would also want to let the local CPU know that if say the partner sent a request to a CSR that was non-existent and that resulted in a decode error, then it may be a good idea to also, because these CSR accesses are mastered by a separate block, the decode errors, they don't go directly to the CPU. So it would be a good idea to also let the local CPU know that somebody tried to access an a non-existent CSR via sideband. So that's what that local error code register is meant for. Is for the sideband subsystem would
Yeah.
interrupt, and then the CPU will come and read that and see what went wrong.
I think we need to designate registers, ones that are that are supposed to be in the local address space versus ones that are intentionally in the sideband address space, because I get a little confused on like which are supposed to be local and which were not, and why a partner would want to access a local register. Like, is there a reason that a partner would want to read the local address register for
No, so that I
errors,
mean this is again
local errors?
implementation specific. So I agree with your point that we should designate certain registers as not to be read by the partner or something like that. The problem is um, I mean we can easily implement this if we are interpreting all the sideband packet in software and then taking decisions in software, right? But then when we are doing it in hardware, the hardware has to create a CSR bus access, and then we are then putting another requirement on the system saying it needs to have an additional access bit to access control for the CSR to say whether that CSR is accessible via that master or not. So not all systems or not all designs would have such access control mechanism. So that's the reason why we do not
Well,
say we do not put a restriction on what can be read or written to by over the sideband, but then we are putting a implementation note saying we should probably put an implementation note saying that the software should be doing software should know what it is doing. So this again falls back to our CSR coherency discussion that we had some time back.
okay.
We are not um, I mean, by design, we are not implementing a system that is foolproof and guarantees CSR coherency. We are putting that as an implementation note that whoever is writing software that sends accesses over the sideband, they need to ensure coherency, that they don't write to a register that the other side can write as well.
Right. So yeah, coherency is not yeah. Okay. So yeah, coherency is not being coherent to multiple masters is the given. I think the issue is, like, some of these things might be on different bus interfaces, right? And some of these might just be virtual registers internal to the block. So like, we probably need to break that up into separate tables. And I
Right.
guess the other thing here too is if you're not, how to say this, if the intention is not to allow a register to be visible on the sideband interface, why are we defining an address for it, right? Or maybe,
So we are
or
defining an so we are defining an address for it so that it is visible in the local address space, meaning the local CPU's address space. That register has to be visible,
yeah, but that should be
and
like
because
an address offset, not an actual address.
correct. But then from a sideband protocol, we are not. I mean, we are exposing the entire link address space of the partner over the sideband protocol. We are not selectively opening up only certain regions. And
Why?
if you have a why? Because I mean, because we wanted to keep the protocol simple, and CSR coherency was not an issue. Like to give a very to give an example of the local error code register, right? So the local error code register was meant for the local CPU to go and read when it was
Uh-huh.
interrupted.
Yeah.
Now, nothing blocks the partner from coming and reading that same register. It can do that if it wants to, but there is no benefit of it doing that, because if there was an error that was logged in that local error code register, we would have already sent a corresponding partner message to the other side to say something bad happened. And the partner message will have all the details of what went wrong. So there is no additional benefit for the CPU on the partner side to come back and again read that same information from the local error code register. So there is no software use case or need to come and read it. And to keep the spec simple, we are not we are not blocking that read, because otherwise your bus fabric that you have to generate based off of your sideband protocol, that becomes a little complicated. So if you want to start hiding certain registers over the
Well,
sideband,
no. It's not about hiding things. I don't care what people want to do in their implementation. I'm just saying, why specify it at all? Make that implementation defined, right? And then if they want to add it to the address space, sure. But you're actually adding complexity to other systems that don't have that in that same address space.
not
By
exactly, right?
requiring.
Because not exactly, because the protocol is symmetric on both sides, right? So whatever register you have on one side, you need to have a same set of register on the other side for the other side CPU to use it. So you cannot say that the local error code register
Let
exists
me
for the local CPU to come and read it, but then in the partner's address view, it is not present. So so you're increasing complexity by having to do that.
Okay, so here's again, I haven't done an implementation of this, obviously, but here's the way I've envisioned it. You have a sideband controller that has a the way I envisioned it would be your local address registers for the sideband controller on like an APB bus or something like that, right? It's
Right.
visible on that bus, and that the link registers, like partner message and all that stuff, are just part of the controller, which is also doing the link controller directly attached to the bow link control, the bow transport layer controller, right? And
Right.
so those are two separate register sets, right? Me doing a local loopback to also add the access to the sideband registers in that scenario is additional complexity I wouldn't normally pay.
Okay, so I can talk about the way I did this. So from a hardware perspective, yes, there is a separate APB. I mean, let's assume that it was an APB bus. So there was a
Yeah.
separate APB bus for CSR access coming from the sideband protocol hardware. There was an APB bus coming from the local CPU, and then there is a simple arbiter that arbitrates between the two APB accesses into a common CSR block. So the CSR block is just a single common CSR block. I didn't have two separate CSR regions, and the reason for doing that is because we wanted full flexibility of what we can write and what we can read over the sideband on the link address space, provided the software knows what it is doing, right? So we did not want to put an additional restriction. Now, if we keep two separate register space, like you mentioned, then we are limiting what we can read on the partner CSR space. So I'm not sure.
Yeah.
I mean, both has its pros and cons. Yeah, but yeah, I
So
mean, from my implementation, we needed full address access,
yeah,
and
I can understand why you would want to do that. There are some advantages in being able to do that. There's some possible testing things and stuff like that. But there's two philosophies I'd like to kind of bring here. Number one, from a standards point of view, my typical philosophy is don't specify things you don't have to specify, right? So if by specifying this, we are, whether we want to add, whether there's functionality here or not, we're adding burden on people, right? If there's a reason to specify this, then we definitely should. But personally, I'm not seeing a reason to. In fact, onto my second point of view from an SoC architecture design, don't give people access to things they don't need access to. From a testing, not testing, from a debuggability and error tracking and things like that, having these registers required from the spec point of view to be in the space adds potential complexity. If you accidentally do an overwrite, not only do you have, other errors potentially, but you're potentially causing all sorts of loop backs and things like that. So we definitely need to, whether these registers are here or not, we definitely need to make them read only to the partner so they don't accidentally cause some sort of loop or trash other registers or break something. But in general, you know, you know, if it was optional in the system whether to include these, I definitely would not. Just from a error tracking and security and everything else point of view, there's no reason to allow those accesses, in my opinion. Now,
Yeah.
there may be a
I mean,
testing point of view, or
Well, so-
or like you said, there may be some sort of very minimal hardware implementation where there's no microcontroller on the other side, and you do want to be able to rewrite that stuff back. I could understand that, but that would be, in my opinion, the corner case of this scenario, not something you necessarily want to specify.
right. So Brian, so just to add, right, so making any register read only from the partner, but then read write from the local, that requires additional implementation or additional support in the CSR module to have a separate access control feature, and not all systems may have that implemented. So putting that in the spec would mean that everybody should be having access control in the CSR. And in my opinion, that probably makes the spec a little bit more limited. But yeah, I'm open to what others think about this. But that's what I feel.
I don't want to step on anybody's current toes, but I view all of that as trivial in terms of an implementation cost.
Right. I mean, yeah, I
just
agree. Yeah, both. I just wanted to say that both have. I mean, both options have their own merit, but they have their own complexities as well. So in one case, you need the software to know what it is doing, and in the other case, you're basically enforcing things in hardware and putting an access control mechanism in place to say this master cannot read a certain register space, or this master cannot write to a certain register space. So yeah, I mean, yeah, if someone else also has some thoughts about it, I think it would be good to speak up.
Yeah, thanks. So being the only guy who's made a second implementation of this thing, right? I did not talk to Ram about this, but my implementation is exactly like his, right? And I did it that way simply because it's much simpler in hardware. So you say it's trivial, Brian, but I disagree. I think it's adding complexity that's not necessarily there.
Okay. Well, then again, and then my opinion would be to remove the, or how to say this. My opinion would be to separate the tables and say, and just make these not required. If that is the case, right? So that, if you have them rewrite, then by all means, then you're good to go, right? If you don't want to do them, or if you think there's a security reason, like I think, or not security is the wrong word, error tracking and debugging, things like that reason, then you can remove access to these things and it doesn't break you from a standards point of view. Because again, per ROM's statements, there's no use case for these to be remotely accessed. If you want them to be remotely accessed, then they're there. If you don't, I think we should have the flexibility to not have them.
Yeah, I'm okay with all that.
But Brian, yeah, I mean, yeah, we can add that note, but then my only concern is when you say you don't need access to them and you want to enforce it in hardware, then you would need an additional block in or additional complexity in the hardware to enforce that. So
But that would
what
be
I'm trying to say is
that would be my decision to pay for that.
correct, exactly. So what I mean, we can probably just make that as an implementation note saying that hardware access control, the access to CSR access control is beyond the scope of the spec. So if
No, I think
systems
all we need to do is mark which registers are local, and mark which registers are the local address space, and mark which registers are in the partner address space, and just say it is optional to whether local addresses are mapped into the partner address space. You can leave all of your suggested addressing and all of that stuff. I would just, again, say local addresses are not required to be in the partner address space. I can put together wording and then you can let me know if you guys are kosher with it.
Okay, that would help probably. I mean, I'm trying to think of a wording myself, but I cannot come up with some good wording that is not ambiguous and it doesn't enforce the end user to implement something more than what they
Just
have already done.
just
But
to make it
yeah,
just to make it non-ambiguous, I would just take the existing table and break it into two sections. One is local registers, one is partner registers, and then there will be a note, implementation note or otherwise, at the end of the local one saying mapping of these registers into the partner address space is optional. That's it.
okay, I would suggest just adding another column to the table to say what kind of access the partner has, because all the registers that you have will have local access. The local CPU can come and anytime come and access those registers. So there is no, I mean, but then yeah, there are some registers like partner. I think partner messaging is probably the only register which requires that the local CPU treats it as a read-only register. So that and then the partner will only write to that register. So that's the most common use case for the partner messaging register. But
Yes.
again, if you have to add that specific access control to ensure that software doesn't misbehave, you need additional hardware to do that. And I'm not sure if we really want to add that in the spec.
And I think
I mean that applies to any
I
register.
I don't even view these as access control, but okay. Like I said, let me try something and then you'll let me know if you're good with it.
Okay, sounds good.
and
So-
that would impact maybe a couple of bits in this table.
It's just no, those are all local anyway. No, it would be
Yeah, okay, yeah, these are configurations. So some of them are like the status inside the configuration.
these are all
but
local registers, right? These are all
Okay.
local. These are all part of the local register. There's a register table. I think was it? I can't remember if it's. It is down. Filter document.
And this these two are also local. 4
Yeah,
and 5.
yeah, you need to find the address map, not the register definitions themselves.
No, scroll back up. The interface registers.
The interface. So
Just keep going.
up. So this is the config register, and these two, the read and write.
No, the one that
physical-
has the register, the map that has the registers with the sideband ID and the.
I think that's lower. I think.
Oh, okay, maybe I.
There you go. It's at the bottom.
There you go. Yeah. So again, all the sideband registers are local registers. All of the, well, I guess.
So again, so the sideband read data is actually not a local register because that read data gets the stores the read response that comes in the sideband response packet, and the local CPU is only expected to read it once the response is received, right? So that's how that's how it is by protocol. But then does that? I mean, but then if you say the local CPU can only read from the read data register, then you're enforcing some kind of an access control in hardware to say only certain masters can write to that register. So that's extra hardware that would be required. But yeah,
I don't understand what you're saying. Why is it not a local register?
it is not a local register because the local CPU will only read from it. So when you're initiating a read into the partner address space, when the read response comes back, that read response gets stored in this register, and then the local CPU will come and read the value of that register.
It's still a local only register. You're not, okay. again, maybe there's a definition here, right? Like I'm not initiating a transaction from the partner, right? That targets that address, right? I'm doing a, that's part of a read command, right? So it's not something I directly address from the partner, and that's what that is something. That's how you define local versus partner access register.
Okay, yeah, I agree. I agree I understand what you mean by local now. So yeah, from that
Yeah.
perspective, yes, I agree that it is local only because it's only the local hardware that writes to that register. So agree.
Yeah. So again, just separating off some of these things or labeling them, we'll say, because we define an address here, right? And this address is defined in relation to the partner's addressing stream over the sideband, right? So the implication is that, the partner is potentially interacting with these registers, but they're not. They're not supposed to touch those registers, right? So again, as Ram and Paul said, letting them being able to access to them, design decision. You could do that anyway, right, outside the spec. But I'm worried about the implications here and over specification in the document for whatever reasons that people may need. If you don't need something, then why do we enforce it?
Okay,
I understand people doing implementation things to simplify it. That's not the issue.
So this would be local remote. And these are local. And this one is local. These are remote accessible. Link interface. And this would be remote.
Is that right, guys?
And now we are, oh, but no, that is incorrect way of adding to this table because that is how the address is. We want to have another column outside the address. We don't want that be part of address bit, right? I don't know how to add a new column here.
Again, I can break up the tables and stuff too.
Okay.
So, like I said, just to make it without adding another column and just to make it exceptionally clear, those highlighted commented registers there, we would just break them out and say, these are local registers. Remote access from the partner perspective is optional. And I think we need, regardless of whether we change access or not, just specifying the intended use case there is the intended access there is would be helpful from a reader's perspective, because again, I got confused when reading it the first time, or actually until recently, in that, okay, some of these things, okay, once you're supposed to be accessing them locally, it's fine. But again, the implication of them being mapped into the partner address space is that the partner also accesses them, where, from our discussion here, they're not supposed to. So again, it's good for the reader to know that.
So I think that's a good progress. We kind of agreed how to add it to the standard and kind of add a hint to possible implementation, but we're not adding impact and making the hardware more complex necessarily. It's optional. So maybe adding a word here that would be helpful. That what is local and remote.
Okay.
and
And then one last thing on the PMR the PMR error realm, the implication there, or at least the protocol, is that whenever you have an error that would impact that one, you write that as a partner message, right to the register, to the partner messages. You write that error to the other partner, right?
Correct. That is correct.
Okay, so we just need to add a note on that saying when an error happens, this is the expected behavior at the link layer partner message.
So this is the local error when the local engine writes into that. And then I think there is also an error message.
Yeah, it's the last one in the table of the PMR message error.
That
PMR
I
codes.
added. This one?
Yeah.
This one I added this one. Was there anyone before that, or maybe it was missed? Okay. So we have now, from the messaging perspective, we are okay. Can we talk about the error command? Do we have enough time? 6 minutes, maybe we can start that. So Brian, if I remember correctly, you said error messaging is at the higher level, and sometimes we can't even process it, and it would be error command. Now,
right. So again, I needed to add, I'd still need to add more text around the error command about
okay.
like what the message format looks like. So I still haven't done that. But
So
yeah.
Brian, just to ask this, right? So do you still see a need for the error command? That's the first question. I mean, if we can do everything via the
Well,
partner messaging, do we really need an error command type in the frame? I mean,
none of
um,
this changes what the error command was meant to do, right? So you were saying earlier, if a controller has like an ECC error, right? Then it needs to write that to its local register, right?
right,
My
right,
point, I think my
right.
point with the error command is probably simultaneously, it would also send an error command to the partner to let it know it had an ECC error, right?
Right, but you
Or
could do the same thing. You could also do the same thing in your ISR routine of the local CPU. So when you're handling the interrupt for that error at the local side, you can have the CPU send a partner messaging to indicate that error command type. I mean, it's just a delayed response, but you would still be able to send that exact same information via partner messaging. But it would
so
go out at a
there's
later stage.
sort of, I think there's multiple implications in terms of like upstream bus errors that I think you would want to know at a lower error, and you'd want to know more immediately on the individual transaction in which it happened, right? Let's say you submit a read command, right? And then you aren't expecting to get data back, right? And so
Right.
and let's say again, right now you're just pumping these things into these registers that you've done mapping. But let's say you do have another bus configuration upstream, right? That this is a direct translation from, for APB or something. You'd want to know that sooner, so that you can either not lock the bus or a variety of other things. And so I'm not saying exactly what you would do with this error command. We're not defining them. We're not doing anything like that. But like having a lower level bus error, I think would be very useful from a protocol perspective here. So you don't
Agreed.
end
I
up.
mean, agreed. I mean, my original implementation does exactly that. So when you especially for a read, if there is a slave error or an ECC error or error of some sort, the hardware itself reverts back with an error command type, and then the other side is smart enough to
Right.
retire a pending read so that it doesn't lock up the sideband hardware.
Right.
But then, yeah, at some point, yeah, I think there was a general consensus that we can do all of that through the partner messaging as well, which is
Right.
technically true.
Well,
So,
sort of,
but it's a delayed response.
it's way delayed.
Yes,
And if you are having back-to-back errors, or if you get into a bad protocol state
right.
upstream, right? Again, from a bus protocol conversion or something like that, it would be very hard to track that. Whereas if you have a specific packet, it's much easier from an error tracking and debug perspective, or signal error noise perspective, to be able to find out what was going on if you have an error packet. And given that we're making it optional, and given that people can not implement it if they don't want to, it's a very useful tool to have in the bucket here, to have a
Agreed. Agreed.
But again, from an implementation perspective, if we're doing this, I would actually differentiate the types of errors too. Like I would put ECC and out of order transactions and things like that. Like if you get a random write complete without a write, things like that, I'd put those bus protocol errors in the error command. And then I would put actual link control errors in the partner message, right? Given I'm assuming that the bus is performing correctly, I wouldn't put ECC and things like that in my partner message error repertoire. I'd put other things like bad link state or something like that in the link control protocol partner message errors.
Right, so the partner messaging form of error, I think we need to put everything, because we are making this error command type support as optional, right? So the partner
No,
messaging
you
needs to
can.
support.
Well, it's optional. You can do whatever you want. We're not defining anything. If people want to
Correct,
do
yeah.
that, if they will, I'm just saying, if I was doing my implementation, that's the way I would break it up.
Got it. Okay, sounds good. Yeah, I agree with you. I mean, yeah, the protocol level errors, I think those can nicely go back as an error command, if an early indication of that error is required. And you're saying that would be added as a optional feature that vendors may choose to support or not support.
Right.
Yeah, agree.
But but again, because we're having it here, people do need to be conscious of the fact that it exists, and that they need to know to ignore it if they don't support it.
Yeah, I mean, at the minimum, I think they have to support it, because they have to at least be able to drop that packet, because that's an unsupported command type.
Right.
So they still need to add some basic support if they don't want to support the feature.
Ideally, they would log it and throw an interrupt, but yeah, they have to at least be able to drop it.
Okay.
So I think we're good. We need to add some text that around the PMR and error, and I think that is most of our error discussion there. I still have it to do, like I said, on the error command message format, which I think is pretty straightforward, but I just haven't done it.
Okay, great, wonderful. Thank you, everyone.
Thank you.
Thanks.
Bye.
Bye.
Bye.